Remember what that was called? The distance around the circle? The circumference? And we had done something about the ratio of the diameter of the circle to the circumference. Do you remember how many there were? How many diameters fit from this string? 3.14. So it's 3 and just a little bit more, which makes pi. So pi is the ratio of the diameter of the circle to the circumference. Alright, so circumference is the perimeter. It's the perimeter that goes all the way around. It's not anything on the inside, it just goes all the way around without missing anything. Alright, now we get to 3D shapes. That's more fun. Alright, so just like triangles, how we classified them by their side and by the angle, 3D shapes are kind of that way as well. But you can classify them in different ways. You can classify them by their faces, their edges, and their vertices. What would be a face of this object here? I have another one. The face would be the flat edge. So how many faces do you think there are going to be on this object?
6.
Riley, there's 6. So there's a top and a bottom, the left and the right, and the front and the back. So there's 6 objects, 6 faces on this object. So the classification would be a cube. And we said we had 6 faces. How many edges are there going to be? What do you think an edge is, Sammy?
An edge is like the line between the two sides, like here.
Mm-hmm. So if a face is the flat area on top, then the edge is where those 2 flat areas meet. So how many edges are there going to be on this figure? 12? Should we try to count them? We have 1, 2, 3, and then there's one in the back here. 4, 5, 6, 7, 8, and we have this way 9, 10, 11, and 12. It's kind of like slanted. So 12. We have 12 edges. What's a vertice? Charlie?
It's the point where 3 edges meet.
Mm-hmm.
So
we had vertices when we had triangles where the two lines came to a point. Well, in a 3D shape, that would where 3 planes come to a point would be a vertice. So how many vertices do we have on here? 1, 2, 3, 4, 5, 6, 7, and 8 in the back. So there's 8. Okay. What would this one be classified as, do you think? What shape is that? It's got this shape that we've been doing a lot. Triangles. And it's got some parallel lines. A rectangular prism. You're very close. Yeah, a triangular prism. Because the one side has a triangle and so does the other side, and then it goes straight up. Because these lines here are parallel. What is the difference between a prism and a pyramid? So here's a triangular pyramid. It's got the triangle on both sides, and like if I had that as the base, then it goes straight up. This one is a pyramid. Doesn't quite go straight up. What does it do? Sophia? All of the edges at the top meet at one point. So this one is a pyramid. We're not going to talk about them today, but we're going to do prisms. Triangular prism is one of the shapes we're doing. Alright, so we said it's a triangular prism. I'll do a different color. Alright, how many faces does it have? Any guesses? Nate?
5.
5? So we have a triangle in the front and a triangle in the back. And we have 3 rectangles. So that'd be 5. How many edges are there going to be? 8? Let's see. 1, 2, 3, 4, 5, 6 of the 2 triangles. 7, 8, 9. There's 9. Close. And vertices. 6. So we have 3 on this triangle and 3 on this triangle. This one is kind of hiding behind that line. But yep, there's 6. Alright, and the last shape we got today is a, what is that? What shape is this called?
The cylinder.
Sawyer? A cylinder, you're right. That is a cylinder. Beautiful, huh? Alright. Now this might be a tricky one. How many faces are there?
2.
2? Well, like if you imagine like you had a can of soup, you'd have a top and a bottom, but what about the outside? What about the label? Like if you cut the label off of a can of soup, what would that look like? Was it okay? A rectangle. If you cut the can of soup label off, it would look like a rectangle. So you have 2 circles as faces, and you'd have 1 rectangle. 3. All right, how many edges? Leslie?
2.
2? So you'd have, where would they be?
The ones connecting the top to the middle.
So here?
And then the bottom to the middle.
In the circle? So the 2 circles would be the edge. Would there be an edge on this side?
No,
Because it's a round. An edge is made when 2 planes connect. And that plane is not flat, it's round. So that there's no edge on there. So there are 2. Alright, and vertices. What do you think? No vertices? Why not? Because there's no points. They're all round. Very good. Alright. And now I'd like to go to area. That's not right, is it? It's not straight across. What is the area of a parallelogram? Or a prism, in this case? Right? So that's this base times side. Alright, what's the area of a circle? That's not good. Yeah, we did this last time. Which one's the area of a circle?
A equals pi r squared.
R squared. Alright, and last one. The triangle. Half of the base times the height. Alright, so on your sheet you should have those formulas written out, because we'll use them again today. Alright. Now, we're going to talk about more than just area today. We're also going to do volume. So what do you think is the difference between area and volume? When we did area, you're just finding one side. You're just finding a 2-dimensional shape, right? Just a square.
Area is for 2-dimensional shapes and volume is for 3-dimensional.
Right. So this is a 3-dimensional shape. So to find how many cubes there are inside of it, how many there is, you'd have to find more than just the area. Does anybody have a guess of what it would be? it has kind of the area in it. So this would be the area of one side of the square, but you'd also need to find the height. So you'd have the base of the shape times the height. Alright, so I have this side of this cube being 2 centimeters. There you go. Okay, so this is 2 centimeters by 4 centimeters by 5 centimeters. So the area of the base would be a rectangle, right? So what would be the area of the base of this figure? You guys can answer together. What's 2 times 4? This is a 2. 2 times 24 is 8. So I'm going to say, how about we write the volume first? Volume equals the area of the base of the figure times the height of the figure. So the area of the base of this figure is a square, so that's length times width. That would be 8. Times the height is 5. 40. So the volume of this cube is 40, oh, we need the units too, centimeters. When we did area, centimeters were squared. With area, with volume, you need to have cubed. Should be up higher. Alright, so the units are very important. Units will be cubed for volume. Alright. Alright, how would you find the volume of this figure? Which one would be the base? The base doesn't necessarily have to be on the bottom, and it's not in this case. Because in a prism, the base, how it's showed here is that, but for our purposes, we're gonna move that triangle and tilt it back so that the triangles are on the top and bottom. So whenever we find the volume of a three-dimensional figure, for now, we're going to use the base as the different shape. And then what goes straight up is going to be the height. So a triangle with the area was half of base times height. But we also have the height of the prism. So to use a different word, another word for height would be altitude. So like if like an airplane was flying overhead, the altitude, how high it is up atop, would come straight down to the bottom of the ground, making a perpendicular line. So the altitude is another word for height. So we'll say that the area of a triangle is the base times the altitude, and we need to say half of that, and then multiply by the height. So what is the area of the triangle on that shape? This is one side, and this 2 is representing for this height. So the base times height is 6, but you also have to take half of that. So it's going to be 3. So the area of that triangle is 3, and then you'd have to also have the multiply by the height. Say, Miss Kendigan had you guys write out the formulas last time, each time. I didn't do that. The formula for the volume was volume equals the area of the whole base, which in this case is a triangle, times the height. So the area of the base of the triangle is 1/2 times base, I'm having a little b, times the altitude or the height. And then we want to multiply the whole thing by the height. So we said that that was 3 times the height. What's the height? 4 inches. All right, so 3 times 4? 12. And what's my units going to be? Inches cubed. Good. Looks a little messy up there. But you get it? Yeah? Alright, what about the area of a cylinder? What do you think we're going to do for that? What's the volume? What's the volume formula? Volume equals area of the base times the height. All right, so what would be the area of the base? It's a circle, right? So pi r squared. And then we need to multiply that by the height. All right, so what is the radius on this figure? So we got 2 millimeters. Pi times 2 squared times the height, which is 1. All right, what's 2 squared? Now you guys have your calculator out. What is 4 times pi? Sammy? 12.6. You guys agree? Yeah? All right. So how is the formula for volume different for the formula for area? It's close to what we have here. Only what we're going to do to make this area into a volume, the volume is going to be the same thing as the base, but you're going to add the height of the figure. So it'd still be pi r squared if I could draw it right, that'd be nice.
Or maybe upstairs on North Floor?
And then times the whole thing by height. What would be the area, what would be the volume of a rectangular prism? Volume equals base times the whole height of the figure. And last one? 1/2
base times height
times the whole thing by height. Good. All right. You think you guys can do this?
Yes.
All right. I'm going to give you some classwork. You can work with your groups to solve prime measure. All right. You can cut.
Okay.